So hi guys, so today we would be talking about some main challenges of machine learning. I'm continuing the series of ML theory topics in machine learning and deep learning. So there are basically two major things that can go wrong in machine learning models. The first is bad algorithm and the second is bad data. So we would be starting with bad data, and maybe the next two to three videos would be talking about bad data only, because this is a very important topic, and your whole machine learning systems and models can get affected with data, because data is everything. So coming to the part, uh, suppose I would just give you an example, that suppose this is a toddler, and you want to make the toddler learn about an apple. What you would simply do, for a toddler to learn what an apple is, all it takes is to point an apple and say apple. Now the child is able to recognize all sorts and shapes of apple. But do you think the things go similarly in machine learning? Definitely no. It takes a lot of data for most machine learning algorithms to work properly. Things work very differently in machine learning. So it takes a lot of data for the most machine learning algorithms that are being used widely in today's world for to work properly. So even for simple models, suppose this is a really simple model. I would just like to give an example of a model based learning we did in the last time. We took thousands of examples to just make a model learn a very small problem. Now for big problems like computer vision and NLP, in this millions of examples are needed. If you haven't seen my TensorFlow playlist on computer vision and natural language processing, I would recommend you to go and see how very big data sets are being widely used for training the models. Means, can you just imagine millions of examples just to identify that this image is a cat or this image is a dog? This is a very small example. So similarly all the algorithms work, but the point is, we all have already talked about this, that how machine learning algorithms affect the models, and the training data, which is the most crucial part of ML models, is affecting the whole arena. So in the previous research paper, which was about a few useful things about ML by Pedro Domingos, we talked that a dumb algorithm with lots and lots of data beats a clever one with a more modest amounts of it. So if you have seen my research paper, you must be knowing that I had explained this in detail around 10 to 15 minutes specifically on this. Uh, I would just show you some research papers in which this thing was proved, that data is the most important thing in machine learning algorithms. Means, you can imagine like this. Uh, this is a graph, and this is the data. This is the data, and suppose this is model X, and this is model Y, this is model Z. Yeah, and this is the accuracy. I would just say this is the accuracy, and you give all the models. So all the models are let's imagine like this model has uh, is not as efficient as you can expect, but this has 7 accuracy, I would just say for now. And this has got 8, and this has got 9. But what if we give this around 1 billion examples, we give this only 50 million examples, and we give this only 30 million examples? There is a very high chance that these models would perform very equally. Means, you can just imagine a dumb algorithm with lots and lots of data can beat a clever one with modest amount of it. Hence, it is also been proved in a machine learning research paper by Microsoft Research, in which it was shown that the test accuracy of a machine natural language processing model had the same result when compared to different algorithms. So you can say like that, from the graph you can see that in a famous research paper published in 2001, Microsoft researchers, the two researchers were named Michael Banco and Eric Brill. I'm sorry if I pronounced their name incorrectly. Showed that very different machine learning algorithms, including fairly simple ones, performed almost identical well on a complex problem of NLP once they were given enough data. So basically this was not NLP, but yeah, natural learning disambiguation. So you can see millions and millions of words were given to them, and this was the accuracy. Means you can understand one thing from this. This is memory based, this is we know, this is perception, this is name bias. Can you imagine one algorithm is really not as efficient as the another one, but they all are giving almost the identical result? Why? Because of the data that you have provided to it. Means you have provided it so much data that the algorithm has no role to play from here. It is all about data when you are comparing both of them. Similarly, this is one very nice research paper from the unreasonable effectiveness of data. This has been done by the three researchers, that is Alon Halvey, Peter Novick, and Fernando Pereira. They worked for Google. So in this the idea that matters, that the algorithms for complex problems was further popularized by this particular research paper published in 2009. In this research paper, it should be noted that however that small and medium sized data sets are still very common, and it is not always easy or cheap to get extra training, so don't abandon algorithm just yet. So after seeing this, one thing is quite clear, that after seeing this, the those results suggest us, means you have seen from the results that algorithms won't matter if you have provided them really good data and in a very huge quantity. So one thing that is quite clear from here is that I would just draw a box here, and suppose in this box there are two layers. One is of data and one is of algorithm. Suppose a particular organization is spending this much on the algorithm and only this much of data. So after reading these research papers and what the experiments say, the results would suggest that the organizations may want to reconsider the trade factor of between the spending time and money on algorithm development versus spending on corpus development. So still there are many companies that focus more on algorithm rather than data, but as the technology is moving forward, people are starting to realize that data consists a very big part of machine learning. That is why data scientists are allocated preparing data, clean data and perfect data for the machine learning algorithms is not a really easy task. When we talk about ML production part, that is TensorFlow extended, you would realize that anomaly change has been included in TensorFlow production part. Let's talk about some TensorFlow extended part. I would just simply search about TensorFlow extended and cleaning data. You would see that TensorFlow has a pre-processing data with TensorFlow transform. This is known as TFX. If you want to go and read this, you are free to go and read this, but it is really not a coincidence that TensorFlow has specifically created a pre-processing data with TensorFlow transform, knowing that the need of data has been increasing from time to time. Hence, from this, what you can say that even for simple problems you need thousands of examples, and for complex I have already told you millions of examples. So what matters is not is all algorithm, but even more than sometimes algorithm, data is what that matters. Here you can see all these four algorithms are performing equally. So does it even matters that which algorithm you're using when you're getting the same accuracy and you're providing the same data? Suppose this algorithm cost them x and this algorithm was costing them 3 times x. Now when they are giving you the same accuracy, if you have provided them millions and billions of data sets, then what's the use of this provide giving the organization 3x when that can be done in x only? So this was the main concept. So this was not the only part of bad data. This is just one part, that insufficient quality of training data is available. We would talk about that in detail. There are two to more three topics in this bad data part, that how data can be cleaned and why data should be cleaned. And we would discuss about one to two previous examples that we have already discussed about cleaning the data. But this is a very major part of machine learning, that the data that we are using should be clean, perfect, and should be in huge quantity. So this was it for the video. You can go and read this research paper. I would just give you the link in the description, and I would recommend you to go and read. They're really awesome, and I would try to cover them in my future research paper explanation series, that is playlist. So thank you for watching the video. Thank you and have a nice day.